Hi everyone, Brent Sutton. Welcome back please to part 4 of the machinery safety webinar series for shop care. And in part 4 today, we're going to be exploring about how to identify and explains the various types of physical machinery hazards. I'm going to break that into 5 components. The sources of harm, how the different work modes around harm when workers are exposed, the 7 common hazards with machinery, some of the other common hazards, which are sort of on the health-related side, and also what's called a machinery hazard checklist. I think one of the challenges that we face with any form of hazard ID is when do you know you've done enough, or when do you know you've identified all the hazards? And the reality is we don't know. We don't know if we have identified all the hazards around in our workplace. So with machinery, what we need to think about is we need to think not so much what the hazards are, but we need to explore what are the sources of those hazards. And with machinery, if we look at the history of harm that's happening at the moment, most of that harm is actually physical harm, acute harm. So starting off with physical hazards is really important. And the machine is made up of 3 parts. The first part is the power source itself. And that power source can be things like electrical, it can be pneumatic, and it can be hydraulic, and it can be other forms of power like laser, radiation, heat, thermal, etc. Then the second component to think about with the physical hazards of a machine is the powertrain itself. What makes it move? Is it gears? Is it chains? Is it sprockets? Is it bands? Those types of things. So what is it actually makes it move? And then the third part of it, the hazards around the machine, are really the tools and the materials, things that are used as part of the machine process. So we could, for instance, have like a press brake machine, and the press brake itself, the hazards are about a sharing hazard between things like your hands and between the 2 surfaces. But also the hazard could also be the sheet metal that we're putting into that machine for either bending or cutting. So the tooling and the materials is also important. And when we think about being exposed to those components, whether it's the source of energy itself, whether it's the tooling or the material, what we need to explore are what are the routine work phases. And I've basically spelt them out in these 4 components, and think of it as a circle. There are things that we do to set the machine up. We could be aligning jaws, we might be adjusting a jig, we might be configuring the distance that the jaws activate, but there is some type of setup process. And during that setup process, we may be exposed to hazards. Then there's the operational stuff, or what we'll call normal work. So when the people are doing their normal work, their routine work around that machine, that is when we're at risk around those natural human components that you might call complacency or distraction or other human factors. But it's just how people operate with the machine. Then the third component is we need to think about, are there adjustments that need to happen during that machine process, that little tweaking, or are people having to clear jams? And then at that machine process, is there some form of cleaning or maintenance protocol that is used with that machine? And cleaning and maintenance in particular is when guards may need to be removed. And that's when those risks exist in those things. So when we think about the hazards present on the machine, we need to look at those lenses of setup, those lenses of operational normal work, that lens of adjustment and clearing jams, and the lens of cleaning and maintenance. Now, here's the good thing about machinery. It can only physically harm you in one of 7 ways. If we understand that the physical harm can happen from one of 7 ways, then it means we can put a lot of direct focus into saying, are those hazards present on the machine? So those common hazards are the drawing in, nip point and trapping, the entanglement, crushing from the machine, being impacted by the machine, being cut from the machine, being stabbed, punctured or shearing, and the abrasion component. And let's explore that in a little bit more detail. And this information can also be drawn from WorkSafe's guidance around the safe use of machinery. So drawing a nip point and trapping. This I see quite often with conveyors. So something is a drawing in or a nip point if the gap is between 5 mil and 120 mil. So the gap between that rollers, what might draw them in, that gap needs to be between 5 mil and 120 mil. What does that mean? Any gap less than 5 millimeters doesn't allow a finger or a fingertip to enter. However, if on the machine a worker is wearing a glove, what you need to think about is, could that glove be pulled in as well? And if that gap is more than 120 millimeters, that means that the arm is able to go through that gap and not be drawn in. So a nip point has to be between, the gap has to be between 5 mil and 120 mil for it to be a nip point. When we think about entanglement, in this example, we have a series of shafts or augers, rotating heads. Typically with a shaft, typically what you're doing is basically a part of the clothing is being drawn in as it comes into contact. Here, the speed that that part operates at becomes an important part of that. Remembering, pardon me, remembering that the degree of harm with that machine is based on the speed and the mass, so the amount of energy that it's producing. So the slower the speed something is, the more reaction time a human has. Something that generates less force, then less harm can be had. When we think about crushing, crushing is basically when a worker can be caught between a moving part of the machine and a fixed object in this example. So for instance, there's a reason why machines need to have spacing of 600 millimeters. So 600 millimeter access ways or walkways or clearways is the minimum requirement for human occupancy. So if you've got, in the case of the figure on the top left-hand side, you can see there that the machine extends out into that space, not providing for that 600 mil clearance that results in crushing. If I think about impact, what I'm seeing more often now is the impact coming from robots in particular. And that is why when we have robots, we actually should use fencing and light curtains or other forms of interlock gates to keep workers away, because it's difficult for the robot to detect the presence of a person. And the other thing that I typically see is that robots basically operate at high speed and they generate quite a bit of force in that process. Cutting, it's the old classic. Once again, even if I look at a skill saw as a good example, or a table saw, that if you think about that adjustable guard, if you're cutting, say, a material of more than 6 millimeters in thickness, as that adjustable guard or self-closing guard opens as the material goes through, the fact is that gap is sufficient for a finger to enter the zone. So just because it's got a guard, you need to check that people can't be exposed to that cutting hazard. Stabbing, puncturing and shearing, probably the most classic ones are around drills or objects coming off angle grinders, things like that. And then we have abrasions, and these are some classic examples around a grinder and also around some sort of bout process but basically abrasion is basically moving and the hands coming into contact with. And this can all be explored in further detail in the free reference document around the safe use of machinery. Or the other really good document is one from WorkSafe British Columbia with their machinery safety guidelines as well. But of course, there are other types of common hazards that exist as well. And we're going to help support you understanding what some of those other common hazards are as part of a checklist process. But what I always say to people is think about the typical hazards around slips, trips and falls, the types of hazards around access, hazards around lighting. For instance, there are different levels of lighting. So say, for instance, if people are doing some form of grading or inspection, that lighting would need to be a little bit higher versus someone who's just, say, sorting a product on a machine, or simply lighting that's just present in the area. So what I'd like to introduce you to is a hazard ID checklist. Now, checklists, I've always got mixed views about a checklist. The problem with a checklist is a checklist by its nature constrains thinking, because we're only going to be engaging on that machine looking for these specific types of hazards. The upside for machines is that we know there are 7 main physical types of hazards that exist with machinery. So this machinery checklist allows us to explore that. And in this example, we're not asking about, is there a crushing hazard on the machine? What we've done is that we've generated and created a series of hazardous situations or hazardous events that can happen on that machine that can lead to a crushing injury. So this example, can some be crushed due to material falling off the plant? Now, if the conveyor is just moving boxes of feathers, then the answer is no, they can't. But if that conveyor is moving aggregate or heavy objects, then they can. And in that checklist, what we're wanting you to do, and would like this to be done with workers, is we want you to explore with those workers how and where can this occur. So this is not a tick and flick. This is about, can we be crushed due to, and we're talking about a list of hazard situations. If the answer is yes, then we want to explore how and where can this occur. So carrying on, once again, this is a classic one for conveyors, uncontrolled and unexpected movement, the lack of the ability for the plant to be slowed, stopped, or immobilized. The classic one there is lack of e-stops or lack of controls where operators typically work. The plant tipping or rolling over, I'm still constantly surprised how much plant is not affixed to the ground, still surprised. Parts of the plant collapsing, that particularly about plant that's overhead, coming into contact with moving parts during testing, inspection, operational maintenance. So just imagine if all the guards have to be removed during the cleaning process, how do we know that not only has that energy been isolated, but how do we know that there's no stored energy on that machine being thrown off or under the plant and being trapped between the plant? So this checklist is going to be provided with you. I've got a note there off to the side with the access to OneDrive, but also ShopCare will be making this document available to you. It is a Word document, so you can do a little bit of change to it if you so wish, but it actually goes through and explores a series of different things, including electrical slip, trips and falls, ergonomics, and the classics around unexpected startup. So it doesn't only just cover those 7 components, we actually gone into it much further. We have adapted that checklist from ISO 12100. ISO 12100 is the international standard for machinery safety. So that checklist has come from a good pedigree. My comment to you is don't rely purely on the checklist as being the solution to all of it. Use the checklist as a way of starting that conversation with the different types of people that work on that machine. So think about, you've got the people who do the normal work, you've got the engineers that might be doing the maintenance or the setup or the alignment, and also think about those people that have to clean the machine. They will all see different types of hazards. Don't forgetting the classic saying, people can only see what they know. That checklist helps us to see things that we may not have necessarily known. In all my years of doing this, I'm continually surprised at what people realize once they actually have a little bit of structure around it, because they may not have seen that hazard, and until they actually understand that they've gained some knowledge or some context, then they see it for the first time. That concludes that module today. And in our next module, module 5, we'll then be exploring the common health and related safety risks with machinery. So don't forget, with machinery, we have two types of main harm. We have the acute harm that comes from the physical hazards, and we have the chronic harm, which comes from the health-related side. So I look forward to connecting back in with you and talking through module 5 about understanding common health and safety risks with machinery. Thank you.